Hi there. Welcome back to my YouTube channel. It's still Joseph Asukwo, J Asukwo, and it's still Golang for beginners. So for today's beginners topic, we are going to talk about blockchain, how the blockchain works, what RPC endpoints are, and then we are going to now connect it to the Ethereum blockchain. We're going to write a Go code that will connect to Ethereum blockchain. So let's get to it. Please, if you haven't subscribed, go ahead and subscribe, like, and also turn on notification. Thank you very much. So starting with what is a blockchain, right? A blockchain is, in its layman language, is just a distributed database shared across many nodes. Nodes are just saying many computers. So you have database that database like distributed database shared across many computers. So what that means is that what is on computer A is the same on computer B, same on computer C, D, and everything, which means that everybody gets to see what is on that distributed database. Everybody that has access to every node has the same information, right? So I compared it to a database. So let's say in traditional database, what you would do is the application sends things to the Postgres SQL. So like I've explained in the past video that software engineering, you're just basically taking data, manipulating data, storing data, retrieving data back, right? I've said this before. So basically, you take the data from like maybe Google, whatever data you are registering, on whatever platform. You take the data and you store it in your database. You need to work with the data. You want to change the data, you can do that with Postgres. You want to retrieve the data, the same thing with Postgres. But on the blockchain, in the other hand, you're not dealing with Postgres or traditional database. You're dealing with the blockchain network. So for this network, for this example, we're gonna use an Ethereum network, right? So you're dealing with a blockchain network, and that blockchain network is basically your application. From your application, whatever information or data you are storing, you send it to the blockchain network. You store it there, and there are characteristics of this blockchain network, which number one is this decentralized. I mean, you should have guessed it by now when I said it's like a distributed database. So it's decentralized in such a way that whatever is on A is on B, so it is populated throughout all the nodes that are connected to that blockchain, right? So blockchain is different. It's just connection of different computer. So it is distributed to all those nodes connected to that blockchain, right? So that's why I say it's decentralized. It is immutable. Like I said, for the traditional database like Postgres or whatever, you can do a patch and offset and you can edit data, but in blockchain you cannot edit data. So whatever you send to the blockchain stays like that forever. So that's why we have things like smart contracts. That's why we use it for contracts, because you cannot go and change it afterwards. So once you sign it, you can't go out, you can't go back and change whatever is on the blockchain, because it is already, once you create it, it's distributed to all the nodes. So are you going to go back to thousands or millions of nodes to start changing the values? No, you can't do that. So it is immutable, and again leads to transparency, right? So like I said, it is, you can, nobody owns it, nobody owns the blockchain, everybody views it, but nobody owns it. So it is transparent. Whatever is there is verified. You can verify it, another person and another node can verify it, other systems can verify it, and it is secure. In other words, to have access to things, there's a concept called cryptography, right? They also have private keys, public keys. We'll get into that in due time, right? So I'm just trying to give you the overall view of how a blockchain works and how it is connected to Golang, right? So the next slide. So now what's the difference between a traditional backend and a blockchain backend, right? So now in a traditional backend, like I've explained before, your front end sends you data. Let's say you're trying to register with an email platform. You put in your data, your name, your your birthday or whatever information. It goes through your Golang API and then saves it in the database. When you need the data again from the front end, you retrieve it via your Go API. You call the Postgres and you get the information out, right? But in the blockchain, it is not. There's one more step to it, right? For you to be able to connect to the blockchain, you need something called an RPC, right? RPC endpoint. So RPC endpoint is literally RPC endpoint is the endpoints that allow is the node that allows you to connect to the blockchain, right? So it's like in this case Ethereum node. So we are going to, for our example, we are going to see how Golang connects to the Ethereum node or to the RPC endpoint, not just Ethereum, RPC endpoint in particular to connect to the blockchain, but we are going to stick to Ethereum blockchain. So we are going to connect through Ethereum node, Ethereum node. So there are different RPC nodes out there. You can use Alchemy, you can use Infura. I think there's Anchor. I don't know if there are more, but these are the three popular ones top of my head that we can use, right? So we're going to try Alchemy on this tutorial, right? So now let's go. So it says instead of querying Postgres, we are querying the blockchain node. Basically, that is just what we are doing when we are talking about blockchain, or the difference between blockchain and blockchain backend and traditional backend, right? So now let's set up an RPC node. I think I've already set up one for this. By the way, this is okay. You can just check Alchemy out. Like I said, Alchemy is one. I've set up one for this already. This is my test environment. So I'm going to show you my key. I'm going to show you my API key. So whatever, I might delete it later after this video. So you can, I'm just showing you how you can create yours, right? Whatever, you can just create yours. So I'm just going to sign in. Alchemy, you sign in. So there we go. So we sign in here, right? This is it. So yours might be a little bit different from here, right? So there's something called, this is first request. They're saying we don't need all this. We don't need all this. Let's create a new app, right? Let's just create a new app and get a new what do you call it? Get a new do something with it. Let's say tests app for beginners, whatever it is. So let's just do maybe wallet. Select what you want to use it for. Let me just use it for wallet or whatever. Then you do next. I'm going to choose the network I want to. Like I said, I want to use Ethereum network, so just Ethereum is fine. So what am I doing? Token API, activate service, let's say node API. So yeah, so these are the things that is saying I should, for wallet, you want to do wallet, these are the things that you have access to, right? So let's just create this app, right? So I'll just show you. Maybe if you're just starting, it might be a little bit different from this. You just, you just probably just need to just register, and then you do all these things right from the beginning, and then you get to this point, right? It is that simple, right? So I'm going to, this is a mainnet. Mainnet is like live. So let's do the test blockchain test environment, and we have different one for Ethereum. We have Hoodie and Sepulia Beacon. So I'm going to just stick to Sepulia. So I'm going to stick to Sepulia. Sepulia is like a test net for Ethereum, right? So now, like I said, if you notice this is your RPC endpoint, which also, so with this, and this serves as your API key. So with this, you can connect to this node being Alchemy, and Alchemy can now give you access to the what do you call it, to the blockchain. That's if you can run the node on your system, right? You can run the node on your system if you want, but this, you can connect to the blockchain through this Alchemy node, right? So let's just call this. So if you call this on your terminal, right? You call this on your terminal, you probably get the same response, as let's just call this. You can see this. So now let's go to switch to our code base. Sorry, let's clear this, clear. So let's try and call this on our terminal. So like I said, it's the same. You're getting this result here, which is what you have here. So now the question is that how do we, let's clear this first. Question is, how are we going to connect it using our Golang code, right? When you say you're a blockchain developer using Go, so with Go, you need to know how to connect smart contracts to your Go, which we're not talking about smart contract now. We might get to that video later. If you're interested in that video of smart contracts with Go, please send me a message. But right now, what we are focused on is connecting blockchain with Go. So we're going to do basic things, yeah. We're going to connect it the same way we did get the last number here in Ethereum blockchain. We're going to do the same thing here. So this is how we connect it. We connect it here. We are going to dial this Alchemy client, and like I said, here you need your API key there. So I'm going to copy this, which comes with my API key, replace that. See, that's the API key that Alchemy gives you so you can have access to their node. So you're going to connect to their client here. When you connect to their client here, and you use the client to call the one of the methods in that their client is block number, which is definitely what they are using here. So you might be confused with what is this. So we are going to, but Golang is going to kind of like decode it to the actual number for you, right? So let's just print out the latest block here. You call the block number. If there's an error, return error here, but print out the latest block. So let's just do go run main.go. Connected successfully. And then this is the block number. This is the latest block number, right? So what you did, you just got the latest block number. It returns the most recent block number. So basically that is what it is there. See, is that easy? All you need is, like I said, we go back to here. Your front end calls your API. So your front end might have sent something. So we are the Go API. The Go API calls the Ethereum node, which Ethereum node now calls the blockchain. Basically, that's what we have here. This is the Ethereum node being called here with the RPC endpoints, and then we call the blockchain, the client, the Ethereum client, the Ethereum node helps us with this client that calls the blockchain and returns the latest blockchain. So let's do something more interesting to us. For example, you might want to get the balance of your I would say wallet, but technically it is the balance of your address, of your Ethereum address, right? Like I said, these concepts we can get to do another video and talk about it, but do send me a message. I need feedback to know what you'll be interested in, right? And please, if you haven't subscribed, go ahead and subscribe, like, and share, please. It goes a long way to encourage me. So we're going to do this again. We're having access to this client here. So this client, this RPC client that we connected to our node, Alchemy node, with these endpoints and our key. We're going to connect it here and get the function and get the method balance at. Now note, this is my Ethereum address right there. So in case you want to send me any ETH, feel free. I won't reject it. But basically, this is my Ethereum address. So you might be wondering, why can't we just use it the way it is? So the thing is that this function accepts an address, not a string. And for you to get an address, this is how Golang converts your address string to an actual address, which you get to passing through this function, right? And that we're gonna print the balance here, the balance from that address. So let me make it clear. Way, they just call it way. That's the balance. So now we are doing a little bit of conversion here. So let's call this, and then I am going to explain what is happening here right after I call it. So now let's clear this. Go run main.go. So now we can see our way here, and then we can see ETH here, right? So what is happening here is that way, if you're in Nigeria, you probably be using Naira and Kobo, right? And Naira, Kobo is like the least value of Naira, right? So if you're in US, you probably be using US dollars and cents. Cents is the least form of the US dollar. So the same thing with with ETH. Way is the least form of ETH, right? So what we did here, we're trying to convert it to convert the balance that was given in way to ETH, so that you can understand it. Like when someone says, I have one ETH, I have one Ethereum, two Ethereum, three Ethereum, that's it. So in actual sense, it comes in way and way. So for you to get ETH, you have to, yeah, it's 10 raised to power 18, right? So it's literally 10 raised to power 18. So that is the conversion rate. So now let's count this. If you're going to do 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17, then the next 0 18, that's why you're having 0.029564 whatever, right? So that is, in summary, in the basic thing, the summary is that is how you can connect from your Go code to the blockchain. So by now you should have a little bit idea about the concept of blockchain and how to connect from your Go code to the blockchain. So when someone says, like, you come to my LinkedIn profile, I say things like, I'm a blockchain engineer, most people might just assume that I write only smart contracts. That's not the case. Not just smart contracts. In fact, Solidity is used to write smart contracts. It means that I can connect from Golang to your blockchain and also communicate with your smart contracts. And there's so much involved in being a blockchain developer, a blockchain engineer. I hope you enjoyed the video. I hope you learned something. Please like, share, turn on notification, and please follow please, so that this encourages me. Thank you very much. See you next time, and I'm waiting for your feedback. Bye bye.